Okay, so we should have gotten up to this part in class. If not, that means I made another video. But nevertheless, we are still in section 7.5. Yes. And the method of partial fractions or partial fraction decomposition, integration by partial fraction decomposition. And so when we're talking about quadratic factors, so irreducible, so a definition here, irreducible quadratic is a quadratic polynomial of the form as we know ax squared plus bx plus c, which can't be written as a product of linear factors. And we're only talking about the real number system because if we're talking about complex, then we can write it as a linear factor if we involve imaginary numbers. But we're only talking about the real number system. So that means if you recall the quadratic formula, if the, and I may have talked about this already, I don't know, but in the quadratic formula, that b squared minus 4ac, that's called the discriminant. And if the discriminant is less than 0, so if, I'm sorry, actually, b squared minus 4ac is called the discriminant. I-N-A-N-T, and if that's less than 0, then you know you have no real solutions because that means your what's under your square root is negative. So, so that means, so that's a quick check. If you're not clear on whether or not your quadratic is irreducible, then you can look at do b squared minus 4ac, and if that's negative, then you know it's irreducible. But if it's greater than 0, that means you might just have some ugly looking numbers, but yet you still might have real numbers. So just keep that in mind. But if you can't use quadratic formula, if it's less than 0, that discriminant is less than 0, then we call that an irreducible quadratic. And there's a certain format we need to use when we're talking about the PFD. So, but a little commercial break here. This integral, I think, will be another that you might want to put to memory. If you recall, we can use trig substitution to solve this, but you might see this one a lot when you're doing your integration using a partial fraction decomposition. So you may want to just put to memory if you have the integral of dx over x squared plus a. Then that equals 1 over the square root of a times tan inverse of x over root a plus c. So that's just something you might want to put to memory. Okay, so let's look at, hopefully this should be example 5 if I stayed in the correct order in my notes on Thursday. We're going to evaluate the integral of 18 over x plus 3 times x squared plus 9 dx. So I will step 1, we find the PFD, and I'm actually going to stop, or you should stop the video here and see if you can. So I started the setup, but I want you to, oh no, I actually don't want you, well, do I or don't I? Well, let's kind of work this together. So we're going to clear fractions, right? Because I don't know if I showed you the second method. Hopefully I showed you both methods in class, but in terms of solving for the variables. But one method might be a little more efficient than the other, so I wanted to show you both. So I'm going to skip some steps. You don't skip steps. Like, you stop it and do each step, but if you need to. But if you know how to just straight clear your fractions, so that will be 18 equals a times x squared. On this stylus, a squared plus 9. Hopefully my writing is okay on this. Times bx plus c times x plus 3. Okay, and what we do here, we have to multiply through, so this is going to be ax squared plus 9a plus bx squared plus 3bx plus cx plus 3c. Then we group like terms. So in terms of x squared, we have a plus b plus x. So in x squared, we have that's an x squared and that's an x squared. And then we look to see what x terms we have, and it looks like we have an x term, 2x terms, so that's going to be 3b plus c. And now we put our constants together, so that's 9a plus 3c. And the way we set this up, hopefully I have room here, and we're going to finish on the next page, or actually I'm going to have you finish it, is this. For those who've taken chemistry or might remember it from high school, we're going to balance this equation. And you balance it because you look to see how many x squared terms are on the left, and you need to balance that with how many are on the right. Well, there's no x squared terms on the left, right? So that means that a plus b needs to equal 0, because then that'll balance off the fact that there are no x squared terms on the left. And we do the same, so we have a plus b equals 0. Then we do the same for x. Well, there's no 0x terms on the left, so 3b plus c also equals 0. And then we have our constants, 9a plus 3c. Well, on the left, the constant is what? 18. So 9a plus 3c equals 18. So I want you to pause this and actually solve. So you have 3 unknowns, a, b, and c, but you have 3 equations. So therefore, you can solve for those 3 letters. And so pause the video and write that out, and then on the next slide, I'm going to show you the solution. Okay, so after doing some algebra, your constant should be a is 1, b is -1, c is 3. Now, if you did it and you checked your work and you did it correctly and you had something different, then let me know, because maybe I've made a mistake in my notes. So please let me know. That's why I want you to do it, to make sure you're doing it correctly. Okay? So once you solve for those values, then we have we can plug those values in, and so we have the integral of 18 over x plus 3 times x squared plus 9 dx is equal to the integral of 1 over x plus 3 dx plus negative x plus 3 over x squared plus 9 dx. And then we need to break this integral up further. We can separate those two, and so we get the integral, that first one stays the same, and then we get the second one, and then that third one. Now here, the second integral, I said you have to sort of on your side work use substitution to solve that integral, but you see you should know what to let your u equal, and then you have your du form of it up there. Okay, and then the last integral here is where I told you need to remember. I will not give you that, so you need to put that one to memory. If you have the integral of dx over x squared plus a, or in this case, so this is, I'm sorry, I think I said at the beginning of the video, this is similar to the trig substitution. It's not, because this is a in the formula, it's a and not a squared. So this is just an integral that you need to put to memory. Okay, and so once you do that, then you have, although you could use trig substitution, but in trig substitution your a would be 3, and in the integral I gave you here, you see there's no square with the a, right? So it's just, in this formula, it's just whatever that a there is there. Okay, so hopefully you note the difference, because I think I confused you all a little earlier in the video. Okay. And when we get all that, it comes out really nice and pretty. That first one is natural log of the absolute value of x plus 3 minus 1/2 natural log of the absolute value of x squared plus 9 once you do that substitution. And this is plus tan inverse of x over 3 and plus c, of course. Okay, so let's look at 5b now. Notice, I hope you note the difference between 5a, let's go back and call that 5a, so call this one a, and 5b. So here in 5b, we have x squared minus 9 instead of x squared plus 9. This, we can reduce this, right? We can factor x squared minus 9. It's actually the difference of squares, so it equals 18 over x plus 3 times x minus 3 times x plus 3. You see we have 2 linear factors that are the same, so we can group those together. And then you remember the format I showed you if you have linear factors that are repeated. So we're going to have the PFD will look like 18 over our denominator equals a over x minus 3 plus b over x plus 3 plus c over x plus 3 squared. We build up from those repeated factors. And find the PFD. I always want to say PDF. Okay. So, and I'm going to end this video in a minute and do another one to finish up. But I want you to pause the video and see if you can figure out the PFD before pressing play and going on to the answers. Okay. So if you want to pause and write this down, you can. This is just actually part of the setup. So this is still the setup, and hopefully you set it up. Now you could have solved it differently, and you can do sort of a variation. So hopefully I showed you both methods in class, but if I only showed you the first method, if you want, you can use the first method to eliminate and solve for a couple of your constants, and then use the balancing method I'm showing you in this video to finish up, right? Because you have a 0 at 3 and -3, so you can actually use that to your advantage to solve for some things first and then balance your equation. So it's up to you how you want to do it. You can do a variation of it here if you need more practice with balancing the equations. That second method, I did that here, so feel free to pause and write this down and make sure you understand how I did each step. And once you do that, you have these 3 equations that you deal with, and 3 unknowns, 3 equations, which means you should be able to solve for them. And our values, I actually didn't state the values. Let me go back and state the values. So our A looks like it was 1/2. Our B looks like -1/2, and then our C is -3. Okay, and we have that. Why do I have, I don't know why I have 2 3s there, so let's take that one out. And, okay, so I factored out 3 and -3. And then, so in terms of integrating, that's a straightforward natural log. That's a straightforward natural log. This right here, you would need to use substitution. So be careful there. Don't go in automatic mode and just think that's natural log. You need to use substitution because that's not natural log. Okay. And then your final answer, hopefully after you do all that, is 1/2 natural log of the absolute value of x minus 3 minus 1/2 the absolute value of x plus 3 plus 3 over x plus 3 plus c. So I'm done with this part 1 of this video. I'm going to continue on. It's one last thing in this section that I want to go over, and then we'll be done. So see you in the next video.